Hey guys, so today on the asynchronous day we're going to be learning about trapezoids and kites, which is going to end off our unit here about quadrilaterals. The thing about trapezoids, and specifically the family tree that we've been making, the trapezoid has exactly one pair of parallel sides, so it's actually not a parallelogram, which is the first shape, or the first quadrilateral we've talked about so far that's not a parallelogram. So we only have one pair of parallel sides. And this is just a regular trapezoid. So let me go ahead and label out some things here, and then we'll talk about it more. Okay, so in fact, on a trapezoid, your two parallel sides are going to be called your bases. Okay, and every angle in a trapezoid is called a base angle. Okay, so we have two pairs of base angles here. Now this is more special when we get to isosceles trapezoids, and there actually aren't a lot of properties to note here. So let's go ahead and move on to an isosceles trapezoid to see what kind of properties that has. Okay, so this is an isosceles trapezoid, and it is a trapezoid because it has one pair of parallel sides. It turns out that the legs on an isosceles trapezoid are congruent, which kind of makes sense if you think about an isosceles triangle. So these legs are congruent. The other property that comes out of this is the fact that the base angles, each pair of base angles, are congruent. Okay, so we have those two at the bottom congruent and those two at the top congruent. And also, if I draw in the diagonals, okay, we can see, and hopefully you can see, but it's not too hard to prove, the diagonals here are actually congruent. And we're going to include that on my quadrilateral chart as well later when we go and fill in this part of the tree. Okay, the last shape that we're going to look at today is called a kite. It's the most estranged from the family tree. So let's look at a kite and then we'll do a few examples. And then that'll be the end of the video for today. Okay, this quadrilateral is a kite, and by definition, a kite is a quadrilateral with two pairs of consecutive sides. By the way, consecutive means next to each other, like AB and AD. It has two pairs of consecutive sides congruent and no opposite sides congruent. Okay, so there's no opposite sides congruent in this shape. Okay, there's also something to note about the diagonals. It turns out that when you draw this first diagonal, what you get is two congruent triangles if you think about the diagonal as the third side. So we get two congruent triangles, so we actually do get some nice angle properties that do happen. But if we draw them both in, the most important property about the diagonals of a kite is that they are perpendicular. Diagonals are perpendicular, okay, which means that this is a 90-degree angle here. This makes a lot of congruent triangles, which will help us find some angles later. But that's about it as far as notable properties of the kite. Let's do a few examples with the trapezoid first. Okay, example 1 says trapezoid ABCD is not isosceles. Okay, which means that we don't have congruent legs, but we do have parallel sides. What is the measure of angle D in terms of x? So I want to find what is the measure of angle D in terms of x. And if we think about a trapezoid as kind of two parallel lines on a transversal, we can see that angle D and x degrees are same side interior angles, which means that they are supplementary. Okay, so it turns out that angle D and x are just supplementary. So that means we could do something like x degrees plus angle D is equal to 180 degrees. And since we want the measure of angle D in terms of x, I'm going to rearrange this equation and we'll get our answer. 180 degrees minus x degrees is going to be equal to d degrees. So we have angle D in terms of x. Once again, just like last time, you can pause this video at any point, and just be aware this key is also on canvas. Let's do another trapezoid. Okay, example 3 says trapezoid trap is isosceles. Before I even move on with the problem, I'm just going to say if it's isosceles, then we should add some things to my picture. Just like in the diagram in our notes, we're going to add in all of those congruent angle marks. I'm also going to add in those congruent leg marks. And why not? Let's just put in the parallel lines as well. So we got all my picture labeled. Find the measures of R, A, and P. Okay, to do this, after we've drawn everything, it's pretty clear to see that this also has to be 107 degrees. Okay, and if we call this other angle X, which is at A and P, we could set up an equation. 2x plus 2 times 107 is equal to 360, because this is a quadrilateral. So if I add up all those angles, I should get 360. I believe that is 214, which means that if we move this to the other side, we get 2x is equal to 146. Okay, and then x, which remember is just angle P and angle A, is equal to 146 divided by 2, which is 73 degrees. Okay, let's do a problem with a kite, and then I'll let you know what I expect from you today. Okay, find the missing angle measures in KITE. Very clever name for a kite. So we're going to figure out what those missing angles are. Okay, and what you'll notice is that one of my diagonals here is already drawn. And if we consider this to be the shared side, we've basically split up this kite into triangle kit and triangle ket. Okay, and these two triangles are congruent by side, side, side. Since they are congruent by side, 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 I know that all of these angles, these corresponding angles, are going to be congruent as well. Okay, so for example, I can already tell that angle E is going to be 100 degrees. Okay, because it has to be congruent to angle I. Okay, also you'll notice that this angle over at K has to be 20 degrees as well, just like the other angle at K. And then finally, if we do the Triangle Sum Theorem with angle ITK, okay, so we set that equal to 180. If I subtract the stuff on the left side, I'm going to get 60 degrees. For angle ITK. So let's just label that in the picture and we'll call it done. Okay, so we've gotten all the angles, and the main property of a kite is the fact that it stems from these two congruent triangles. So I made sure to include this example in what I got. Really quick, we're going to head over to the chart from last time, the quadrilateral chart, and we're going to finish filling that out. You can finish filling that out on Canvas. I'm just going to basically show it to you. So let's head there now. Okay, as you can see from the chart, what separates the trapezoid branch of the tree is the fact that it has one pair of parallel sides, as opposed to the parallelogram side of the tree. And the kite is all by itself because nothing is actually parallel in a kite. Now, I do expect you to kind of go to the chart key on Canvas to fill the rest of this out. I don't need to draw all of this and talk about it with you. This video is already 10 minutes, so. Here's the chart. You can find it on Canvas to finish filling it out. I'm going to end off today with a bit of instructions because the assignment we have is a little bit special. Okay, so for today, if you haven't already, you're going to complete warm-up 6-6 on Canvas. Obviously, you've already head to Delta Math because I actually just made sure that this video was part of your assignment. This is actually how I'm taking attendance today, is watching 100% of this video. That's actually part of the Delta Math assignment. There are instructions in the module for today that will kind of explain what I mean by that. And the last thing is, okay, so there's a new assignment attached to that Delta Math. It's not that bad because I didn't want to overload you right before we start reviewing for the final exam. There is a new assignment though. Don't forget the quizzes from last time. That's going to be open until Friday night. And if you have any questions, of course, just message me on Canvas. I think that's enough time out of your day, so I'm going to go ahead and end the video here. If you have any questions, of course, once again, message me on Canvas. I will not leave you on red. Have a good day. I guess I'll see you on Friday. Okay, I'll see you Friday. Later, guys.